Happy spring break. For those of you who are taking the time to try to fill this table out over spring break, you will be happy that you did because the endocrine system makes a lot of sense, but there's a lot of detail that you have to memorize. So my challenge to you is to try to get this table done as much as possible, but please make sure that you can edit it as we go through the classes. So, like, don't write it in pen, or if you type it in, make sure that you can edit it. Okay, so first off, there are two different forms of the table up there. One of them is a PDF, which of course is easy to print out. This one is a Microsoft Excel form, which you can actually type into, you can resize. If you have the PDF and you have the full version of Adobe Acrobat, you can edit that one as well. But basically, whatever you want to do, but make sure that you either make it erasable or you can type over it or anything so that I can, you'll get the vast majority of it down over spring break, and then we can fix anything that was confusing when you come to class. Okay, so first off, please note that there are all of the endocrine organs here. And by the way, not all endocrine organs are glands. For instance, we already learned in the cardiovascular system that the heart makes a hormone. Okay, so you are responsible for all of these that are numbered. Yes. And I think I was wrong. There are 34, not 32. And then you learned one from the heart as well, so you can add that one in. That's ANP. Okay, so let's talk about how you fill this out. So basically, this is me telling you that you're responsible for 7 different hormones that are released from the hypothalamus. So where are you going to find those 7 different hormones? Well, there are a bunch of different places, but if you really want it to be narrow, first place you would look is in your notes. So please look. In your notes, what I did is, after you get past the hormone structure and synthesis, which I'll come back to in just a second, there are these 2 hormones that are not released from the hypothalamus, so those do not go there. And then there are these 7 that are released from the hypothalamus. So you can get in the abbreviations all right here, and then you are responsible for the long names of the hormones too. So please note that in your notes, all of the hormones are in green, so you know that that's something you should pay attention to. So pretty much everything that's in green in your notes should find a place on this column. Okay, so where do you look up what GnRH stands for? Well, really anywhere. But it's absolutely in your textbook. You could also look it up pretty much anywhere on the internet. Or remember that there are videos of me teaching all of this from last semester if you just scroll back a little further in the YouTube channel. So you've got 7 different hormones from the hypothalamus. Now, so you can start with the abbreviation, and then if there is an alternate name for the hormone or an example of the hormone, let me show you what I mean. So like right here, do you see that this one is called somatostatin, which is abbreviated SS, or it's also called GHIH, which is growth hormone inhibiting hormone, or GIH, which is growth inhibiting hormone. So that's a hormone with 2 or 3 different names, and you need to know all of them. The reason you need to know all of them is because when you get into pathophysiology or another class, I don't know which hormone name they're going to use. Please note that not all of them have multiple names, though. Dopamine, you learned it as a neurotransmitter. It also behaves as a hormone, and its other name is PIH, which is prolactin inhibiting hormone. So, and notice it says, what is the target of each of the above hormones? So that's one of the other columns that you have right here. So let me just go ahead and tell you that that simplifies pretty readily, because all 7 of those hormones right here that come from the hypothalamus, which is the purple box, end up going to the same place, which is this peach box called the anterior pituitary. So that makes it relatively easy. So this figure has a pretty simplified, version of that. Okay, so that's those 7, and then there are going to be 6 that come from the anterior pituitary. So you just scroll down find pituitary, find anterior pituitary. And there are 1, 2, 3, 4, 5, 6 with their long names right there. Okay. So each time it's got this assignment here, it's something that you're actually going ahead and doing over spring break. Now, as far as this effect, you may or may not want to wait until you get to class to do that column. If you can figure it out, that's fine, but it's just a blurb. It's not a paragraph. So if you get everything else done, then you can leave the effect for class. And then basically you'll be able to say, okay, I know what GHIH does. GHIH comes from the hypothalamus, goes to the anterior pituitary, and it's called growth hormone inhibiting hormone. And the effect that I will teach you, unless you want to go through the videos now, is it inhibits the release of growth hormone. Okay. And then the clinical significance, you don't have a clinical significance for every single one of them. So which ones do you have? So if you run into clinical connections or a disorder, then you put it over there. So for instance, these two right here, pituitary dwarfism and pituitary gigantism, they both go with the same hormone. Actually, all three of these do. Acromegaly, they all go with growth hormones. So do you see hyposecretion of growth hormone during childhood? So basically, when you got to growth hormone, which comes from the anterior pituitary, you would have 3 different ones for clinical significance, but you're not going to have them for most of these things because most of the disorders are not relevant to you. Okay, so and then you're going to scroll down and you're going to go to the posterior pituitary. 2 hormones from the posterior pituitary. This can confuse you if you don't read carefully because these 2 are actually made in the hypothalamus, but they're released from the posterior pituitary. They're the things that they're released because of an action potential. So they kind of like your textbook likes to call them neurohormones. And please note that there is a clinical connection with that hormone ADH. So that would go over on the clinical side. That's diabetes insipidus. Okay, so it's relatively self-explanatory. The only thing that I am going to need to tell you is, 2 things. If there is no disorder or clinical significance in your notes, then even if it's in the textbook, you're not responsible for it. And then the other thing is, let's look at the column that we haven't addressed yet. And the column that we haven't addressed yet is the chemical column, the chemical class of hormones. Okay, so with chemical class of hormones, the reason you care about the chemistry is because lipid-soluble hormones are going to find their receptors in different places than water-soluble hormones, which of course you already know. And lipid-soluble hormones tend to stay around a little longer than water-soluble hormones, and they don't get cleared through the kidneys, of course. So basically with chemical class of hormones, with this column, there are going to be 4 possible answers, and each hormone should have one of the 4 answers. There are, and they are right here, by the way. So each hormone will either be an amine, and there are 2 categories of amines, water-soluble amines and lipid-soluble amines. And they're all right there. So after you find the hormone, it'll be right there. And then there are going to be peptide or protein hormones, and this makes up the vast majority of them. So you can just put peptide if you want to. Your textbook says peptides are different than proteins because proteins are bigger, but they're in the same category. So they're basically strings of amino acids, and they're going to be water soluble. Okay, so it's either a water soluble amine, a lipid soluble amine, a peptide, or this last category are called steroid hormones. And the steroid hormones are lipid soluble. They're all derived from cholesterol. So those will be a separate category. And I'll go ahead and give you a little hint. All of the hormones from the adrenal cortex are going to be steroids. So I went ahead and filled it in there for you. And most of the hormones, but not all of them, from the gonads are going to be steroids. So you can look at the notes to figure that out. And then, FYI, since most of your hormones are peptides, if you can't remember, guess peptide, because there are more of those than anything else. So I gave you a little hint in here. With the adrenal cortex and all of those steroid hormones. Let me give you one last thing to clarify for you. So when you get to the adrenal cortex, let me show you that. Where are you, adrenal cortex? There we go. Okay, so with the adrenal cortex, and this is the last thing, and then I'm done. Basically, any hormone from the adrenal gland is going to be a steroid. So quite often they call the whole collection of them corticosteroids because they're from the adrenal cortex and they're steroids. And then there's 3 different categories, and I wrote them in here for you. There's the glucocorticoids, and those tend to regulate sugar. There's the mineralocorticoids, and those tend to regulate salts. And there's the gonadocorticoids, and those tend to regulate sex. But this is just categories. So the corticosteroids includes all of them, and then 3 separate categories. But please note, in the separate categories, you have at least one hormone. So for instance, I've got the glucocorticoids, and then look at your notes, guys. The glucocorticoids include these 2 hormones, cortisol and corticosterone. So those would go right there because they're green, right? So the glucocorticoids include cortisol and corticosterone. And then look at the mineralocorticoids. Mineralocorticoids, there's only one example. You've got aldosterone. And then the gonadocorticoids, we've got the androgens, including DHEA and androstenedione. Does that make sense? Hopefully it does. Okay, now if it doesn't make sense, then you get it as close as you can. And then as we go through this, you correct whatever needs correcting instead of having to fill in the whole thing after spring break. Okay, these down here, you are not responsible for yet. It's a placeholder because we're going to talk about quite a few of those as we finish the semester, except for the one that we did in the last set of notes, which this would be the one from the heart, which is ANP or ANF. Its long name, let's just pretend we're filling this out, is atrial natriuretic peptide or factor. Since it's got peptide in the name, it's going to be a peptide. The target, you guys should remember, it actually goes to the kidneys and the vessels. The effect is lowers blood pressure. And I can't think of a clinical significance for that one. So this one is already done because we've done it in the set of notes we're working on right now. Okay, so I'm going to post this for you. Do not let yourself get frustrated if you can't fill in the whole thing because you will be working on it. And this is basically the same stuff we're going to go through in your notes. You're just going to be a little less overwhelmed because you've already gotten some of it down. Okay, and now have a good spring break. I will see you guys next week.